welcome. Let's try to solve another Leetcode problem. 3316. Find maximum removals from source string. You are given a string source of size n, a string pattern that is a subsequence of source. So for example, this is our source and this is a pattern ABA. It is a subsequence of the source ABA. And a sorted integer array target indices. So this is the target indices and it is sorted like 0, 1, 2. And inside it's going to be the indices like 0, 1, and 2. So the indices will target indices that contain distinct numbers in the range 0 to n minus 1. So for example, 0 to 2, it is inside 0 to n minus 1. So for this example, n equal to 5, n minus 1 equal to 4. So we define an operation as removing a character at index from source such that. So index is an element, so any index is going to be an element inside of the target indices, and the pattern remains a subsequence of source after removing the characters. So we have the constraints. So the first one is the index. This is inside of the target indices. The second one is the pattern. The pattern is going to remain a subsequence of the source after removing the character. Yeah. So for this example, we can remove the character b for this character b after removing. So this ABA is still a subsequence of this ABAA. Or we can remove this b. It's going to be similar. But how many operations we did? We just did one operation. We can remove this b, or we can remove this b. But either this b or this b definitely is going to be one operation. It is not two operations. So this is why we're going to return 1. Yeah, so performing an operation does not change the indices of the other characters in source. So for example, if we remove C from ABC, the character at indices 2 would still be B. So after removing this C, the indices will not change. Otherwise, we cannot solve the problem. So we're going to return the maximum number of operations that can be performed. Yeah, it is a lot of reading. And also, let's just check the constraints. It's going to be n equal to 10 to the power 3. And for the pattern's length, source length, and indices length is gonna equal to n. So this means maybe we can solve the problem by using dynamic programming. And the target indices is sorted in ascending order, and it is inside 0 to n minus 1. And the source and pattern is lowercase English letters. And the input is generated such that pattern appears as a subsequence in source. So this is just some constraints. I think if we understand the problem, why not just make the problem a little bit easier? Because of the target indices, it makes the problem a little bit difficult. So why not let's just ignore the target indices? Maybe the problem is going to become easier. So if we ignore the target indices, here it is 0, 1, 2. So what about the target indices is 0, 1, 2, 3, 4. I mean, we're going to include all of them, all of the indices. So this problem is going to become easier. What if we just include all of them? So this means for the source, for each of the characters inside the source, we can delete it, we can remove it, or we can keep it. We can remove it or we can keep it. So this means the problem is going to become a longest common subsequence problem. Yeah. So the idea is that we're going to use dynamic programming. And for each of the characters, so for example, for this character A, we can decide, we can have two decisions. We can keep it or we can remove it. Yeah, so this is the basic pattern to solve the problem. Because we will ignore all those target indices. It means all of them can be selected to remove. Yeah. So what if this character A equal to the last character A from pattern? The last character A from the source equal to the last character A from the pattern. Yeah, even though they are equal or not equal, it doesn't matter. But for our decision, for each of the characters inside of the source, we can have a decision to keep it or remove it. So if we remove this character A, if we remove this character A, what's gonna happen is that we're gonna have a subproblem. It's gonna be AB BA, and here it's gonna be ABA, but we need to plus a 1. So this means we have one operation. Yeah, so here currently we will ignore that. Definitely we cannot remove this A because it is not inside of the target indices, but let's just ignore it and make the problem a little bit easier to understand. So for this character A from here, if we remove it, it's gonna become ABBA here for the source, and the pattern gonna be the pattern gonna be the same. We just have the decision to remove this character. Yeah, so this is one of the conditions. If we remove a character, definitely we need to plus 1. Yeah, now for the next character, this A and this A here. Now, even though they are equal, so what if we have a decision to just keep it? Yeah, so the keep it means we're gonna keep this character A and we're gonna keep this character A. It means this is a valid case. This A gonna equal to this A. Yeah, so if they are equal, we're gonna just choose the subproblem. It's gonna be like Fi minus 1 and J minus 1. So it's gonna become the subproblem. We're gonna just need to check the subproblem. Maybe the subproblem gonna have the maximum value, but we don't need to plus 1 because we're gonna use it. This means we're gonna keep this character A. Yeah. So now for the next character B, we still have the decisions to remove it. If we just remove this character B, for example, we need to plus another one here. Yeah. Now let's just move to the next for this character B and this character B here. Yeah. And what if we just we just keep it? So this means we're gonna use it. Yeah. So we're gonna use this B and we're gonna use this B. So here we're gonna go to the subproblem. It's gonna be Fi minus 1 and J minus 1. And now we have this A and this A. Yeah. If you decide to remove this A, for example here, if you decide to remove this A here, definitely it's not possible because we still have an A from the pattern. So this means it's not possible. We're gonna return a negative infinity. But what if we just keep it? This means we're gonna use it. This A and this A, they are equal. So this means we find a valid case. So this means we're gonna return a 0. So this 0 just means a valid case. A negative infinity means invalid case. But how many operations? It's gonna be 2. Yeah. Now let's just come to the problem of the index for the target indices. So now we cannot choose this index, for example, for the let me just ignore delete all of them. Yeah, we cannot choose this index for example this index A here, this index this is the index 4 and this is the index 3. We cannot choose that, and we can only choose index 1 or index 2. So this means there's only one operation instead of 2 operations because we cannot choose index 3 or index 4. But how can we check? We can directly use a set to check if index we are choosing it is inside the target indices or not. We can use a set. Otherwise, it's going to be time limit exceeded. Yeah. Now the time complexity is going to be n squared. If we are not using a set to check if this index is inside the target indices or not, it's going to be n cubic. Definitely, it didn't work. Now let's just start coding. I think basically we have the basic idea to start coding. Let's define function f and I and j. Now let's just ignore this one, the target indices. This means we can choose all the indices from 0, 1, 2, 3, and 4. So the condition is that we're gonna check the index I. If I is less than 0, so this means we used all of the source. Now we're gonna check j. If j is more than or equal to 0, so definitely it means it's not possible because we are not consuming all characters of the pattern. Otherwise, it means we consumed all of them. We're gonna return a 0. Yeah. Now we're gonna have the first case. It's gonna be the, let's call it delete. So we're gonna let's just call it maybe, yeah, let's just call it maybe just a delete. So we're gonna delete this character A. Yeah, we're gonna delete this character A. This means we're gonna consume one of the operations. Yeah. So the result gonna be f with I minus 1 and j. Yeah, for the pattern it's gonna be the same, but for the source we're gonna delete the last character. For example, here. Yeah, if we do one of the operations, so basically we need 2 plus 1 because we did one of the delete operations. Yeah, so this is our result. Even though if they are equal or not equal, it doesn't matter because we have the decision to delete it. Yeah. Now we have another decision is not deleted. So if j is more than or equal to 0, and if they are equal, if the source I are equal to the pattern j. So if the two characters are equal, and j is inside of the boundary, because for here we didn't check j is less than 0. So this is why from here we're gonna check j gonna be more than 0, and then we're gonna check this case. Otherwise we're gonna have the as case problem. So we're gonna check this j gonna be more than or equal to 0 for the pattern. So if they are equal, we have the opportunity. We have the opportunity to keep it because they are equal. Yeah, even though they are equal, we have the opportunity to delete it. It is from here. Or they are not equal, we have the opportunity to delete it. Yeah, it doesn't matter. But if they are equal, we have the opportunity to keep it. So otherwise, how can we keep the pattern gonna be a subsequence of source? So this is why we're gonna check it from here. To check the pattern gonna be a subsequence of the source. If they are equal, it's a good idea to check it. Yeah. So we're gonna update the final result. It's gonna be the result with f I minus 1 and j minus 1. Finally, we're gonna return the result. Now we're gonna call the function. So the function call gonna be, let's say, r minus 1 and c minus 1. And let's just update the r and c. R gonna be the length of the source, and c gonna be length of the pattern. Yeah. So currently we didn't use any information of the target indices, but this is okay. We just ignore that, as I said before. Yeah, let's just check. As we can see, the result is 2. This is what exactly we analyzed before. If we ignore the target indices, it's gonna be 2. So this is okay. Yeah. For this one, if we ignore the indices, it means we're gonna include 0, 1, 2, 3. We're gonna include all of them. So the result is gonna be 3. This is also okay. Yeah. Now let's just include the indices. Actually, it's gonna be easier, and we just need to plus. Yeah. So here is 1. Yeah. Here we are sure that we're gonna include all the indices in the target indices array. Now we're gonna check. Because here we consumed index I. So here basically we need to plus I inside the target indices. Yeah, if it is inside, we're gonna plus 1. Otherwise, we're gonna plus 0. Now let me just run it. Yeah, now at least it works, but definitely it's gonna be time limit exceeded because this is a set and the time complexity is gonna be n cubic. Definitely it didn't work. Let's just try. Yeah, so if it didn't work, why not let's just transform it, the array into a set. Maybe it works. You know, it didn't work. Yeah, it passes some testing cases. Now we turn the array into a set. Maybe we can pass more testing case. Let's just try. Yeah, maybe it didn't work. Yeah, you see? We passed one more testing case, but there are still but there are still 4 more testing cases that didn't work. So this means we have to optimize the problem. Actually, we have a memory exceeded problem. So let's just clear the memory a little bit for Python. We can clear it like that. We're gonna store the final result into result variable, and then we're gonna clear the cache. In Python, we can use f.cacheClear, and after clearing the cache, it means we clear the memory for each running of the algorithm, and then we're gonna use the new memory, and then we're gonna clear it, and then we're gonna return the final result. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works. Although the speed is slow, but at least it works, and we can analyze the time complexity. So the time complexity is going to be n squared, n going to be 3 times 10 to the power of 3. Yeah. So there's another case that for this j is more than or equal to 0. But what if you don't want to check it from here? So this means you have to check it from here. Yeah. So this means if j is less than 0, this means we've already consumed the pattern, but there's still something remaining inside of the source. So this means we still have to return something. We're going to return a sum of 1 if let's just use another index k maybe, if k inside the targeting indices, else we're going to return 0. So for k in range, we have to check everything inside of the range from 0 to I. So this is why we're going to use I plus 1. This means we've already consumed the pattern, but there's still some characters inside of the source. So we still have to check one by one if it is inside of the target indices or not. Yeah. If you don't want to check j more than or equal to 0 from here, this is also okay. Now let me just run it. As you can see, it works, and let me just submit it. Yeah, as you can see, it also works. Maybe you still want to optimize a little bit. Yeah, because the index I and j actually if this index I is less than index j, so for example, we have 1 character inside of the source and 2 characters inside of the pattern, so definitely it didn't work because there's less characters in source. Definitely it didn't work. We have 1 character a inside the source and 2 character ab inside the pattern. Definitely it didn't work because ab can never become a subsequence of a. So we can stop it earlier. So this means we can return a negative infinity. Yeah, but if it is not, so this means we're going to check if I is less than 0. If I is less than 0, this means on j definitely it is less than 0 because for here we've already checked. Yeah, another case is that if I is less than 0, so we're going to return 0 directly because the pattern has already consumed, and here it is less than 0. It means the source has also consumed, so we're going to return 0 directly. So, but for here we can optimize a little bit of the time complexity. Before it is n squared, now it is n squared divided by 2. Yeah. Now let me just run it and submit it to check if it is faster than before. Yeah, as you can see, it is faster than before. It becomes 4 seconds, but basically that's everything we can do about it, because for using the DFS with memorization, the time is gonna be really slow. I think basically that's all about it. Thanks for watching. See you next time.